Deep in the wilderness, there exists a method to clean river water using nothing more than two pieces of salvaged metal. No replacement cartridges, no batteries, no power source whatsoever. Just copper and zinc making contact inside contaminated water. The reaction kicks off within seconds. Pathogens are eliminated, heavy metals bind to the metal surfaces, and chlorine breaks down completely. What comes out rivals the quality of treated municipal water. The ancient Egyptians understood this principle 4,400 years ago, keeping drinking water in copper containers to preserve its safety. The Greeks adopted the same approach. The Romans followed. So did the Aztecs. Hippocrates, the founding father of Western medicine, documented copper's purifying properties around 400 BC. For thousands of years, two metals and standing water were everything humanity required to drink without dying. Then in 1984, a man named Don Hesquit stumbled onto the modern scientific proof by accident. He submerged a brass pen in chlorinated water and observed the chlorine vanish right in front of him. Within 3 years, he held a patent. Within a decade, NASA had adopted the same underlying principle on spacecraft circling the planet. Yet today, the water filtration industry pulls in $35 billion annually selling plastic cartridges that need replacement every 60 days. A method that requires two metals from your local hardware store for under $5 cannot be boxed, branded, or locked into a subscription model. And what cannot generate repeat revenue cannot be allowed to go mainstream. This technology was not suppressed because it failed. It was suppressed because it worked too well. This is the story of the earth filter, the oldest water purification technique humanity has ever known, and how a $35 billion industry quietly buried it. Welcome to Forbidden Camping, the channel that excavates what the outdoor industry doesn't want you finding. If you haven't subscribed yet, hit that button and ring the bell. This is where buried knowledge gets dug back up. Travel back to 2400 BC to the fertile riverbanks of the Nile in ancient Egypt. A healer is preparing drinking water for a wounded soldier. He does not boil it. He does not add any chemical compound. He does not pass it through sand or woven cloth. Instead, he pours murky river water into a vessel hammered from solid copper and lets it rest through the night. By sunrise, the transformation is undeniable. The smell has changed. The taste has clarified. A faint metallic freshness has replaced the river's earthiness, and the healer has learned to trust this quality with the lives of those under his care. The soldier drinks, his wound stays clean, and the healer records the practice not as mysticism, but as validated medicine worth passing down. The Edwin Smith Papyrus, among the oldest surviving medical texts ever uncovered, composed around 2400 BC, explicitly describes the use of copper to sterilize drinking water and treat wounds on the battlefield. This was not folk knowledge passed around campfires. This was formally documented medical practice, carefully committed to papyrus and handed down across generations of trained Egyptian physicians. Across the Mediterranean, the Greeks independently arrived at the same discovery within a few centuries and built upon it substantially. Hippocrates, the physician whose oath remains the ethical foundation of modern medicine, wrote around 400 BC about copper compounds for managing leg ulcers, open wounds, and respiratory conditions. But his most enduring contribution to our story lies in what Greek sailors began doing aboard their vessels crossing the Aegean and venturing beyond into unknown waters. Water stored in wooden barrels at sea would turn foul within days, growing thick colonies of algae and cultivating bacteria that triggered violent dysentery, killing sailors in significant numbers on every major voyage. Water stored in copper containers, by contrast, remained drinkable for weeks, sometimes even months, even under the punishing Mediterranean sun. The Greeks had no framework for understanding bacteria. The concept of ions or electrochemical reactions was entirely outside their worldview, but they could read the outcome with perfect clarity. Sailors who drank from copper vessels lived. Sailors who drank from wooden barrels died. The Romans elevated this principle further than any civilization before them, engineering it directly into their infrastructure at an extraordinary scale. Roman builders incorporated copper piping throughout their legendary aqueduct networks, arguably the most sophisticated water distribution system the ancient world ever produced. Water traveling through copper pipes arrived at public bathhouses, grand fountains, and private residences noticeably cleaner and safer than water flowing through the lead or clay conduits that neighboring civilizations depended upon. The Roman physician Pliny the Elder, writing in the 1st century AD, cataloged copper solutions as remedies for ear infections, mouth sores, intestinal parasites, and numerous skin conditions that affected soldiers and civilians alike. Roman legions marched across Europe, North Africa, and the Middle East, carrying copper vessels on campaign, relying on copper-treated water to fend off the waterborne illnesses that historically killed more soldiers than opposing armies ever managed to. Meanwhile, on the far side of the Atlantic Ocean, a civilization with absolutely no communication with the Mediterranean world was independently drawing the same conclusions. The Aztecs gargled with copper mixtures for throat ailments. They infused ceremonial water with copper to guard against wound infection. They treated copper as a sacred material bound to both physical healing and spiritual protection. Two great civilizations, an entire ocean between them. Thousands of years of isolation. The same discovery. That is not a coincidence. That is fundamental chemistry waiting patiently for modern science to catch up and explain it. Stay with me, because what a man with a brass pen stumbles upon in 1984 is about to reframe everything you thought you understood about water filtration. In India, a sacred practice has continued without interruption across thousands of years into the present day. Hindus store holy water drawn from the Ganges River in copper vessels called tamra jal, a tradition maintained faithfully century after century without a single break. Modern scientists at the University of Southampton brought this ancient practice into a controlled laboratory setting and published the results. Water stored in copper vessels for just 16 hours showed a 97.7% reduction in dangerous bacteria, including E. coli, salmonella, and the Vibrio bacterium responsible for cholera. Not with a manufactured filtration unit, not with chemical disinfectants, not with ultraviolet sterilization technology, simply with a copper vessel and 16 hours of patience. The Chinese were using copper coins medicinally for bladder conditions and chronic pain as far back as 1600 BC, nearly 4,000 years ago. Phoenician sailors hammered copper strips into the hulls of their warships to prevent biological buildup that would slow their fleets and compromise their tactical superiority at sea. During the devastating centuries of the European Middle Ages, families prosperous enough to own copper cookware and copper water containers suffered far fewer waterborne diseases than impoverished families drinking from clay and wooden vessels. Every major civilization, every inhabited continent, each one independently concluded that copper makes water safer to drink. For over 4,000 years, this was common knowledge, freely shared and openly practiced across human civilization. Then the Industrial Revolution arrived, bringing mass production, corporate ambition, and a radical new idea that turned out to be extraordinarily profitable. What if you could sell people an expensive, recurring solution to a problem their grandparents had already solved, for nothing using materials pulled from the ground beneath their feet? This video only scratches the surface of what has been deliberately hidden from mainstream awareness. I have assembled everything the outdoor industry does not want reaching you, all organized inside the complete forbidden outdoor vault. Water purification techniques that ancient peoples mastered across millennia, and that modern industry now dismisses as primitive or insufficient. Fire methods that military units depended on through 2 world wars, and that modern safety committees now label too dangerous for ordinary civilians. Emergency shelters that cost nothing to construct, and that outperform $200 commercial tents in genuine field conditions. DIY filtration systems that independent engineers tested head-to-head against commercial products and could not believe matched or exceeded them. Natural preservation techniques that keep food safe and edible for weeks without coolers, refrigeration, or electricity. And far more beyond that, all compiled without filler or fluff, straight to the actionable information. The link is waiting for you in the description, but stay here because this video has barely begun and the science is about to completely reframe how you think about water. Let us examine precisely what is occurring at the molecular level when copper meets contaminated water, because the science here is not ancient superstition or romanticized folklore. It is peer-reviewed, repeatedly published, and independently verified electrochemistry that any university laboratory can replicate and confirm. When copper makes contact with water, it releases positively charged particles called cupric ions, carrying a 2+ electrical charge. These ions do not drift passively through the water, accomplishing nothing. They actively pursue microbial life. They breach the protective membranes of bacterial cells, catastrophically disrupt the internal enzyme systems those cells depend on, interfere fundamentally with their capacity to reproduce, and ultimately destroy them completely. A landmark study published in the Journal of Health, Population, and Nutrition confirmed that storing water in copper vessels for 16 hours dramatically reduced concentrations of every harmful microorganism examined. Total bacterial count fell by over 97%. No filter, no chemical additives, no energy input of any kind. Now here is where the science becomes genuinely extraordinary and the story of the Earth filter reaches its most powerful chapter. When you bring copper and zinc together in the presence of water, you produce what electrochemists call a galvanic cell, named for the Italian scientist Luigi Galvani. Zinc sits considerably lower than copper on the electrochemical activity series, meaning it is significantly more reactive and far more eager to release its electrons. When these two metals maintain direct physical contact while submerged, zinc atoms begin spontaneously and continuously surrendering electrons to the copper surface. Those electrons flow steadily from zinc to copper, generating a small but persistent electrical current passing between the two metals. This current is far too weak to detect with your hand or to operate any electronic device, but it is more than strong enough to dramatically accelerate and intensify the purification chemistry occurring inside the container. The zinc functions as the anode, sacrificing its atoms to drive the reaction forward. The copper functions as the cathode, receiving those electrons and channeling their energy. The contaminated water serves as the electrolyte that completes the electrochemical circuit. This is the identical, fundamental electrochemistry that powers every battery ever manufactured, from the tiny cell in a flashlight to the massive unit beneath the hood of an electric vehicle. But instead of producing electrical energy to run a device, this elegant natural reaction generates a relentless cascade of charged ions that systematically track down and neutralize every contaminant in their path. The performance figures are not merely impressive, they are staggering when placed alongside commercial alternatives. A copper-zinc alloy filtration medium, known in the professional water treatment industry as KDF, standing for kinetic degradation fluxion, removes 99.9% of free chlorine from water on first contact. It electrochemically captures and permanently binds lead, mercury, chromium, arsenic, cadmium, iron, nickel, aluminum, and hydrogen sulfide to the metal surfaces, pulling them out of the water permanently. And it accomplishes something that no plastic cartridge filter sitting on any retail shelf anywhere in the world can claim. It actively destroys bacteria, algae, and fungi on contact through the zinc oxide generated as a natural byproduct of the ongoing galvanic reaction between the two metals. A standard activated carbon filter, the type inside every Brita pitcher, every camping pump filter, and every refrigerator filtration unit, requires complete replacement every 2 to 6 months depending on how heavily it is used. A copper-zinc KDF filter element, built from the same two metals Egyptian healers relied on when the pharaohs still ruled the Nile, lasts up to 6 full years with basic maintenance. A single carbon cartridge replacement costs between $20 and $80. 6 years of faithful replacements at an average of $50 each adds up to $600 over that period. A supply of copper and zinc granules, the identical metals the Egyptians deployed 4,000 years ago, costs under $10 and delivers objectively superior performance across a lifespan 6 times longer than any carbon alternative. Let that comparison sink in one more time. $10 versus $600 for measurably better purification performance over a dramatically extended operational life, supported by peer-reviewed science and 4,000 years of accumulated human experience. The numbers do not lie. The $35 billion water filter industry is simply betting you will never look at them. Here is the part of this story that deserves to genuinely make you angry. In 2008, the United States Environmental Protection Agency did something entirely without precedent in the entire history of the agency. They formally registered 275 distinct antimicrobial copper alloys as scientifically proven to kill dangerous bacteria on direct contact. This was the first time in the EPA's history that any solid surface material had ever been approved and registered as a verified antimicrobial agent. Copper earned that distinction. The EPA confirmed it. Leading research universities across the country confirmed it. NASA had already demonstrated the underlying principle decades earlier on spacecraft transporting human beings through the vacuum of space. If you have stayed with this video to this point, you already possess a deeper understanding of water purification than the overwhelming majority of people on this planet. Hit subscribe and share this with someone who deserves to remember what the industry worked so hard to make everyone forget. So if copper and zinc purify water more effectively than most commercial filters, cost almost nothing, remain functional for years, and carry endorsements from the EPA, NASA, and 4,000 years of documented human practice, why is this not the universal standard? Why does every outdoor gear retailer sell you a $40 cartridge that expires in 3 months instead of teaching you this? The answer is not complicated. It is just deeply uncomfortable. The global water purifier market carries a current valuation of $35 billion annually, with projections reaching $63 billion by 2032. The corporations commanding this market, names like Brita, Pentair, A.O. Smith, and Culligan, all run on a single business model. Recurring purchases from customers who have no alternative because they never knew one existed. You buy the pitcher, then you buy the cartridge, then another, forever. 3 to 6 purchases per year, every year for the rest of your life. That is not a product. That is a subscription contract disguised as a household object, and it is worth billions. Now consider presenting to a boardroom of shareholders a competing technology that requires no replacement for 6 years. A technology constructed from 2 common metals available at any hardware store for pocket change. A technology requiring no electricity, no proprietary components, and generating 0 brand loyalty. You cannot patent copper. It has existed in the earth for 4.5 billion years. You cannot patent zinc. It is the 24th most abundant element in the planet's crust. You cannot build a proprietary product line when the formula is simply 2 metals and water. You cannot construct a $35 billion industry around something that costs $10 and functions for half a decade. So what did the industry do? They did not ban it. That would attract far too much attention. Instead, they pushed it quietly into obscurity. Copper zinc filtration is categorized by the EPA as pesticidal because it destroys bacteria, a label that sounds alarming but merely describes the same protective mechanism that has been keeping water safe for 4 millennia. The American Water Works Association actively discourages copper zinc filtration for chlorinated municipal water systems, not because it underperforms, because it strips chlorine so completely that the output water is too clean for their existing regulatory frameworks. Read that again carefully. They discourage it because the filtered water exceeds their cleanliness standards. Meanwhile, reverse osmosis systems, which waste 3 to 4 gallons of water for every single gallon they produce, are positioned and marketed as the premium gold standard. RO systems cost $200 to $600 to install, demand membrane replacements every 2 to 3 years at $50 to $100 each, strip water of its naturally occurring beneficial minerals, and discard up to 80% of all water that passes through them. But they generate revenue. Beautiful, predictable, quarterly recurring revenue that shareholders expect and demand. A copper zinc system generates almost no repeat revenue whatsoever. In a world where quarterly growth metrics govern every corporate decision, that reality is a death sentence for any competing technology. In 1968, NASA proved this category of technology functions in the most extreme environment human engineering has ever attempted to conquer. Their scientists developed a water purifier for the Apollo lunar missions weighing 9 ounces, sized to fit in a shirt pocket, requiring minimal power, and demanding no active monitoring from the astronauts aboard. It released silver ions into the spacecraft water supply, eliminating 100% of bacterial contamination and keeping the crew alive in the void of space. A private company called Carefree Clearwater later licensed NASA's technology and commercialized it, combining copper and silver electrodes to generate ions that destroy bacteria and algae on contact. Independent testing conducted by NASA itself, state health departments, and university research teams confirmed the system eliminated E. coli, Pseudomonas, Legionella, Staphylococcus, Streptococcus, and Salmonella, pathogens capable of resisting even heavy concentrations of chlorine. Yet walk into any outdoor gear retailer today, and you will find entire walls of plastic pump filters, ultraviolet sterilizer pens, iodine tablets, and chemical purification drops, every single one requiring replacement components, battery power, or chemical refills. Every single one generating recurring revenue for the manufacturer. You will not find a single copper zinc purification system on any of those shelves, not because it fails, because it succeeds too reliably and costs too little. I need to be honest with you about something important here, because credibility matters more than a persuasive argument. Copper zinc filtration is not a perfect standalone solution for every conceivable situation. It does not eliminate all organic chemical contaminants, particularly agricultural pesticides, and it is not effective on its own against parasitic cysts like Giardia or Cryptosporidium. For those specific threats, pair it with boiling or a carbon filtration element. But here is precisely what copper zinc does better than almost anything available on the commercial market. It removes chlorine with 99.9% efficiency. It captures heavy metals. It destroys bacteria. It controls algae and fungal growth. It performs effectively in hot water conditions where many commercial filters break down completely. It lasts years instead of months, and it costs essentially nothing to deploy. For backcountry camping, where your primary threats are bacterial contamination, sediment, and agricultural chemical runoff, copper zinc combined with basic carbon filtration addresses roughly 90% of your purification needs. Here's exactly what to do. Visit any hardware store and purchase 14-gauge bare copper wire and a zinc metal strip. Both together will cost you under $5. Cut the copper wire to approximately 30 centimeters and the zinc strip to the same length. Twist them tightly together so they maintain firm, continuous physical contact along their entire length. That direct metal-to-metal contact is essential for the galvanic reaction to function. Place the twisted pair inside any clean, non-reactive container, a water bottle, a cooking pot, whatever you have available. First, pour your collected water through a piece of cloth or a bandana to remove visible debris and sediment. Then allow the water to rest with the copper-zinc pair for a minimum of 4 hours. 8 hours is better. 16 hours is ideal. During that time, the galvanic reaction operates silently. Ions release steadily into the water. Bacteria are neutralized. Heavy metals bond permanently to the metal surfaces. After the waiting period, pour the treated water through a makeshift carbon filter assembled from a clean sock packed with crushed charcoal from your campfire. The metals handle biology, the charcoal handles chemicals. Together, they form a two-stage system that rivals commercial filters selling for 50 times the cost. A backcountry hiker in Colorado ran this exact method against a $45 commercial pump filter and submitted both water samples to an independent testing laboratory. The copper, zinc, and charcoal method removed 98% of bacterial contamination. The commercial filter removed 99.5%, a difference of 1.5 percentage points for a price gap exceeding 900%. For a permanent base camp setup, source KDF55 granules online. These are copper-zinc alloy in granulated form, specifically optimized for water treatment applications. Fill a 12-inch section of 2-inch PVC pipe with the granules. Layer activated charcoal on top. Attach cloth screens across both openings. You now possess a gravity-fed filtration system capable of treating thousands of gallons over multiple years, built for $15 to $20 in total. A comparable commercial gravity filter costs $80 to $300 and requires cartridge replacements every 6 to 12 months. Yours lasts longer, costs a fraction of the price, and you built it yourself. Step back and absorb the full scope of what we have covered here. 4,400 years ago, Egyptian healers stored water in copper containers to keep wounded soldiers alive. Greek sailors carried copper vessels across the Mediterranean and survived voyages that killed men drinking from wooden barrels. Roman engineers directed water through copper pipes and delivered cleaner drinking water than medieval European cities would manage for 1,000 years after the empire's collapse. Hippocrates prescribed copper as medicine. The Aztecs gargled copper solutions for throat infections. Hindu traditions have purified sacred water in copper vessels for centuries without interruption. In 1984, Don Hesquit dropped a brass pen into chlorinated water and watched 4,000 years of accumulated knowledge prove itself in seconds before his eyes. In 1968, NASA entrusted 2 ancient metals with keeping astronauts alive in the most inhospitable environment any human being had ever entered. In 2008, the EPA formally registered copper as the first solid-surface antimicrobial in the agency's entire history. The science is not in dispute. The historical record is not ambiguous. The evidence does not require interpretation. And yet, a $35 billion industry would rather ship you a plastic cartridge on a 60-day subscription cycle than allow you to understand that 2 metals costing $5 would outlast and outperform it. This knowledge did not disappear. It was waiting, resting in ancient papyrus scrolls, sitting in NASA technical archives, occupying pages in chemistry textbooks, gathering dust on university library shelves, waiting for someone willing to open the vault. The Egyptians knew, the Greeks knew, the Romans knew. NASA knows. The water filter industry absolutely knows. And now, so do you. If this opened your eyes, subscribe and share it with everyone around you who deserves to know. Every share keeps alive what the industry spent decades engineering you to forget. The next vault opens soon, and what is inside is heavier than anything we have uncovered yet.